evaluating algebraic expressions. Let's go ahead and talk about a couple definitions about things that we're going to be looking at. So for number one, it says a symbol that is used to represent a number is called, and this is going to be a variable. Okay, so we're going to be using letters to represent numbers that are going to be changing. Now, a number whose, this is number two, a number whose value always remains the same is going to be called a constant. Okay, so it's just literally a number. And we call them constant, we call them coefficients. They're not going to change. It's just going to be exactly the same thing. Let's go to number three. Whenever we're talking about an algebraic expressions, we're talking about a collection of numbers, variables, operation symbols, and grouping symbols. In other words, you guys probably know by equations. You see an equation, you see things with letters and numbers, and that's what we call algebraic expressions. And we've been working with this one the entire year. Finally, the last thing that we're going to go over for the vocabulary today is going to be if we give a specific value to a variable, then what we can do is we can evaluate an algebraic expression. So what that means is that we're going to be using a number. They're going to give us a number for the letter. So if you guys are looking right here, let's go ahead and look at the example number 3. This is going to say evaluate an expression, and it's exactly the same thing that I was talking about. Now, they're telling us that x is going to equal to 3. What we need to do is we're just going to be substituting that letter for that number. And then we're just going to do the operation that is there. So let's go ahead and do that. So if we look at number A or letter A, this is what's going to happen. So if I substitute x for 3, it looks something like this. It's going to be, I'm going to put in parentheses. You don't have to because, I mean, it's going to be representing the same thing, but I just want to represent what's happening here. So it's going to be 3. It's going to be in parentheses, and it's going to have the power of 2. Now, that means that I have a 3, and then it's going to be multiplied by a 3. So a 3 times 3 is equal to 9. So if I were to evaluate A, when x is equal to 3, my answer is going to be 9. Okay, so pretty easy. That's the first thing that you can do. Literally, you substitute for the letter, and then you do the operation that's there. We're done with A. So whenever x is equal to 3 for A, my answer is 9. Let's go ahead and do the next one. So we have same thing. We have an algebraic expression. They're telling us that x is equal to 3, so I'm going to substitute x for 3. Now, that means how many 4s do I have? I have 3 4s. So it's going to be 4 times 4 times 4. Pretty easy. All I have to do is multiply. So 4 times 4 is 16, and then 4 times 16, I believe 68. I might be completely wrong, but I'm almost guaranteed that's going to be correct. So that's going to be my answer for this one's just going to be 68. Let's go ahead and do the next one. And this one's same thing. It's an algebraic expression. So I'm going to be substituting 3 for every single x I see here. So this one's going to be look like this. 3 parentheses 3 squared plus 4 parentheses 3 plus 1. So let's go ahead and simplify. Well, technically we do append it, so let's go ahead and simplify this, the exponent first. So I have 3 squared, which we did it earlier, is 9. So I have 9 times 3. 9 times 3 is 27, so that one's going to stay like that. Then 4 times 3 is 12, so that's plus 12. And then that one stays the same. Let's go ahead and add them. So I'm going to add those two. That's going to give me 9 and 3, right? 39, and then plus 1. Add those two together, and my answer for this one is 40. Pretty easy. That's literally all I'm doing. Okay, it's just evaluating expressions, literally substituting a number for a letter. Let's look at the bottom ones. And I actually want you guys to work this ones out and see if you guys can figure it out. It's only 4 problems, so it should be pretty easy. You're going to be substituting 3 for x and 5 for y on every single one of this one. So make sure you do those 4, and then that's the end of this note. That's it.